file. This one is using 50 startup CSV file. Okay, so this is again a new data set. Let me also upload that data set. All the data sets that has been used in various Jupyter Notebook files, which I also be like distributing, will be from Kaggle only. Okay, and you can get the descriptions of various files from the Kaggle too. Okay, it's uploaded. Now, if you remember, in the iterative imputer, we were taking the help of a classifier, okay, of a classifier for predicting the missing values. In this particular notebook file, I have used linear regression. And in the paper that we have seen in the morning, which was yeah, this one. This was the paper that we have seen. They were using deep learning models for iterative computer, and those were like DBN, deep belief network, and multi-layer perceptron. Okay. Instead of using deep belief network and multi-layer perceptron, I have simply used here linear regression. If you want to perform the same experiment, what you have to do is you have to remove this linear regression with the deep belief network and the multi-layer perceptron. Okay, and that would also require the configuration of additional libraries like Keras and TensorFlow. Okay, and for that you need to install it on your local system. Okay, what I'll do is let me run and load my libraries. Linear regression has been loaded from sklearn package. Okay, pandas obviously data frame, and numpy obviously like the array operations. Okay, in the data set there are columns like R&D spend, administration, marketing spend, profit. Okay, and what we are doing is we are actually rounding off it by 10,000 because the number might be very huge number. It would be in e raised to the power 5. So we are just rounding off each values. Okay, this one is something like I'm fixing the seed value because I want constant random values. Every time I want 21, 37, 2, 14, and 44 for my instances. This will be fixed. Okay, because I'm fixing the seed value. And then if I see samples, so every time I'll get these 5 instances, which will be 21, 37, 2, 14. Okay. So now I want to remove some columns, and that is because okay, we have in the morning I guess we have taken example of 4 columns. Okay, and here I'm taking example of 3 columns, 1, 2, 3, because like we can also take the 4 column, but just to have a simplest like this file is carrying each step one cell, like it's an iterative algorithm where you want this algorithm to run in iterations. Okay, and what I did is I did not implemented the complete algorithm in one go. I implemented it step by step, where 0th iteration will be given by certain cell. Then post completion of those cells, you would be getting the first iteration value, then second value. Like every iteration has been broken into the cell. Rather, if you want to implement it, what you have to do is you have to implement it inside the loop. Okay, and that loop should run till the difference between the predicting value and the previous value becomes 0. This was the criteria that we have done in the model. Okay, So what we are doing is we are limiting our focus from 4 columns to 3 columns only, and will perform some, like intentionally I will add some not a number values onto this, like onto this values which I am right now showing. I'll run and show you what I'm trying to say. Okay, I got some warning message. Okay, take care. Now see, what we have done is I have original data this one, and then intentionally I added some missing values on these location, like first row 0th column, this one not a number, then third row, which is your this one, first column not a number, and then last row last column is your not. So I intentionally added 3 missing values into the data set. Okay, and then we are starting with the first step. If you remember, first step we said that impute this NaN values with the mean of that particular column, mean of that particular column. Okay, it ran, and just see those not a number is now removed by their corresponding mean. Corresponding mean matlab the column mean. Okay, they are being removed, and then are now removed with the corresponding mean on that particular column. Okay, that is great. Like this was the first step. Okay, then what we said is we will be now starting our loop for each column. What we will do, we will try to predict this 9.25. Okay, keeping it again to be NaN and making this particular column as a test data and rest other column to be training data. Also, since we are estimating the first column, so we will also make R&D spend to be our label. Okay, that is why. I'll show you how. What we are doing is we are copying this your mean wala value to df1. Okay, and then removing the first mean, that is 9.25 to not a number. I'll show you. See, this 9.25 has been removed, and now NaN like missing values there. What we have to do is we have to make the 37th wala row as our test data, and the rest 4 rows will be used as a training. And amongst that training and testing, these 2 columns will be like administration and marketing spend will be used as your feature, and the R&D spend will be used as a label. Okay, see, I'll show you how. What we are doing here is use first 3 rows to build a model and use the last for prediction. Okay, so we want this NaN to be predicted by our learning model. So what we have done is we have created a training data carrying 0th instance, 2nd instance, 3rd instance, and 4th instance. Okay, and the number of features are 1, 2, 3. 1, 2, 3. Okay, 1, 2, 3. No, obviously 0th column will not come. 1 say 3. Like these 2, administration and marketing spend. Okay, and you get the output. This is your what? This is your training data that you have created. Okay, and why is obviously this column R&D spend. Yeah, this is the column. Okay, now what you'll do is you will feed both training as well as the label into a linear regression column. Yeah, and simultaneously after training, we are also predicting which one the first row ka, or the first row is this one. 5 and 20 will be given input, and now this nr.predict will predict the value of what it is predicting. You can see that 23.1. It is predicting 23.1. It's a numpy array. Okay. So now what I have to do is I have to remove this NaN with the value 23.14, and with this this is what I am doing over here. And let me see my new data. Yeah, 23.1. This was the value predicted by the NR. Now for the second what you have to do, you have to make administration wala column as your label. Okay, and NAN was, I guess, this 11.25 tha, this was NAN. You have to make this again NAN, which is your this step. Yeah, NAN ho gaya. Now make this row as a test instance and rest as training. Make this to be label and rest to as a feature instance or feature values. This is what we're doing over here. And then form Y, again train linear regression and predict the value. And value you can see is here is 11.06. What you have to do is now remove this NAN with 11.06. Done. Similarly, for the third column also, you will be repeating the same. Okay, let me run and show you. And then again, okay, this row will now be treated as a training instance, a testing instance, and rest will be treated as training. Create the training data. This is feature matrix. Label. Done. Train the model. Predict the value. Value is 31.56. So you will be replacing NAN with 31.56. Here, your first iteration is over. Like you have completed for all the columns. Now what you do is, for the next iteration, you will compute the difference of the values with respect to the mean, original mean that you have computed. Okay, and this is what we are doing over here. See, all the values are 0 except those values which was predicted by your model. Okay, and you will continue the same step for each column again until and unless these values are also becoming or converging towards. This is what the iterative input is. Okay, rest of the, like, now from here onwards, again I have created new data frame df2 which is copying df1. Okay, this NAN is again included on the desired places. Then again rest, like this will be used as a training instance, rest will be used as training. Label, linear regression model, train it, predict it, and then replace it. Okay, 23.78, replace it. So I have actually broken the whole step into the finer, like very individual steps like this. Okay, rather than making such a complex code, what you can do is, it's basically these 5 steps are there. What you have to identify that location, replace it with not a number, create X, form X, form Y, train it, predict it, and replace it. Then again, what you iterate towards next column, find the not a number, replace not a number, form X, form Y, linear regression, train the model, predict it, and replace it. This is the basic step which needs to be kept inside a loop. Okay, for each column, you have to perform this operation for each column until how many times? Until the difference of new matrix and the old matrix becomes 0. This is how the iterative input works. Okay. I hope, like, again further if I run, it is nothing but the same thing, but for next iteration. Okay, and this paper was doing the same thing. Which one? Yeah, this one is doing the same thing, but not with LR, but with DBN and MLP. And apart from that, they have also conducted experiment for the discretization. Like with the discretization also. Like they have also used discretization technique where the missing values would be now termed as bin, okay, or they can be replaced with their bin indices, and then further they will be used as a normal data for classification or whatever the task is. Okay, I hope you got the idea that how the iterative input is. Okay, for your experimentation purpose, what I can do is, let me post the codes on to And if you have any doubt, you can ask your doubts.